All right, today we're going to go over 2.2 standard form of a quadratic function. This is part 2. And the essential question is, how do you interpret the graph of a quadratic function to solve real world problems? So what we're going to be doing is we're going to be identifying the key features of a quadratic function, and we're going to link that to a real world situation. Okay, so we got this example. A water balloon has shown or was thrown from a window. Okay, the height of the water balloon over the time can be modeled by the function y equals negative 16x squared plus 160x plus 50. So we know that the x, or the input, oops, let me change that. So we know that the input is time in seconds, and we know that the output is y, height, in feet. Okay, so this graph, we know that the graph is modeling that equation. Okay, so the equation that was given to you is also given to us as a graph, and they're asking us the following questions. What was the maximum height of the water balloon after it was thrown? How long did it take to reach maximum height? How high was the window? How long did it take the balloon to fall into the ground? Estimate if necessary. And how high was the balloon after 7 seconds? Okay, so all of those are key features, and we need to be able to identify them or try to understand which ones are they. Okay, so for example, let's take question number 1. What was the maximum height of the water balloon after it was thrown? Well, given the graph, we can see that the maximum height was somewhere over there, right? Well, we can't really see where it is. It could be around 450, you know, it's somewhere between 400 and 500 feet. Well, how can we figure this out? Well, we know that that point, your maximum point, is also your vertex. So if we find the vertex, we should be able to find the maximum height. Well, the equation is given to us in the format of, in the standard form, right? So the vertex is basically not given to us. So what we're going to do is we're going to be using the formula, and we're going to find the vertex by using the formula. So let's go ahead and do that. So the formula is x equals negative b over 2a. So I'm going to go ahead and plug in my values. This is a, this is b, and that is c. All right. So b value is 160, and my a value is negative 16. So let's go ahead and calculate that. Well, we know that the top is going to be negative 160, and the bottom one is going to be negative 32, since 2 times negative 16 equals negative 32. All right, now I'm going to see if those actually simplify, and they do. Negative 160 divided by negative 32 actually equals to positive 5, which means that the x value of my function is 5. Well, what did I just find? I actually found not the vertex completely, but I found the axis of symmetry. So now I know that the axis of symmetry is at x equals 5. Well, that's still not the max or the maximum height. I need the h part of my hk value. So I need to find my y value. So what I'm going to do is I'm going to go ahead and plug that back into my equation, in my original equation. So I got negative 16x squared plus 160x plus 50. And I'm going to go ahead and plug in my x value, because remember, I want to find my y value. So I'm going to take my calculator, because I do not want to complicate myself. And I'm just going to plug that in. So once you plug that into your calculator, you get y equals 450, which is the last part of my vertex. So now I know that my vertex is 5, 450. And I'm looking specifically at the y value, which means that for question A, the highest or the maximum height of the water balloon is 450 feet. Cool, perfect. So check. Question number 2, how long did it take to reach maximum height? So I'm still looking at the vertex. How long did it take for the balloon to reach 450 feet? Well, if we look at the vertex, my axis of symmetry is 5, and 5 determines the time, which means it took 5 seconds to reach maximum height. So the first 2 questions just how to deal with my vertex, and actually I'm going to write that on top. So this is 5 seconds. All right. Third question is, how high was the window? Well, where is the window in terms of the example? Well, the window has to be somewhere over here. I don't know what point is that, because it's somewhere in between 0 and 100. It could be 50, could be 60, could be 80. I'm not sure. So what do I know? Well, I know that that point, specifically that point, it's your y-intercept. Well, if it's your y-intercept, all I got to do is find the y-intercept given the equation, and we know how to do that. To find the y-intercept, all we got to do is plug in x equals 0. So 0 for x. So I'm going to take my original equation. So negative 16x squared plus 160x plus 50. And I'm going to plug in 0 for x. Now, remember, when you do this, we already know that the y-intercept is actually just the c value, because what's going to happen when we plug in 0? Well, negative 16 times 0 squared is just 0. 160 times 0, it's also just 0. So I am left with y equals 50, which means that my y-intercept is 0, 50, which means that the height of the window is 50 feet. Check. All right. Now, the next question says, how long did it take the balloon to fall into the ground? Estimate your answer. Now, luckily, we are given the graph. If we were not given the graph, this would be much, much more harder to figure out. But I can kind of estimate that I'm going to hit 0, or I'm going to hit the floor around this point, which is your x-intercept. Now, so far, we don't know how to do that. We don't know how to find the x-intercept, so we're just going to estimate it. And I'm going to estimate that it's about 10.5 or 11. So it takes about 11 seconds to reach the ground. All right, if you don't have the graph, you can also, plug in x values to see at what point you're going to hit 0. You can also graph it using your graphing calculator. So there's a few options. All right, and the last question is, how high was the balloon after 7 seconds? Well, 7 seconds is somewhere over here. And I don't know what that point is, but how can I figure that out? Well, you can use the x value, plug it into your original equation to figure out what is the y value after 7 seconds. Basically, we're going to let x equals 7 seconds. And we're going to plug it into our original equation, which is y equals negative 16x squared plus 160x plus 50. And let's just plug it in. Notice that I'm gonna put it around parentheses first. And now I'm gonna go ahead and plug in 7 seconds. I'm gonna go back to my calculator because I'm not gonna complicate myself, and just plug it into the calculator. And the calculator says y equals 386, which means that after 7 seconds, your balloon is 386 feet height. Okay, so again, all of those questions, how to deal with the key features of a graph, you just got to make sure that you understand which key features is the problem referring to.